Alright, it's been a while. I'm a bit late to putting up this homework 4 video, and my iPad is on low charge, but let me just get straight into it. Let's go to comprehension section 2, because you should have finished all of the first one in lesson, and just in case you don't understand anything that's going on in the second comprehension. So I'm just going to read through it. Okay, so his grandpa's built a house in Lancashire. It was his grandpa's house, but his dad lived in it. Okay, and he's always thought of it as his dad's house. Might be important. My grandpa said, built with his bare hands. Seems to be an exaggeration, no? Probably used some tools. Brick by brick, like a pioneer assembling a mud home on the Lancashire fields. Nice simile. So many years before. 6-bedroom ranch house by himself stuck with me. If I learned that he did not actually make any part of the house. Okay, that's interesting. Bit of a plot twist. So that he could pay others to build the house. Okay, paid others to build it. Still, even today, I tell my own kids that he built it himself. It was a crowning achievement in life. So why not let the legend outlive the truth? Interesting. I'm gonna actually look at the question before I finish off the next 2 paragraphs. So the narrator in the passage can best be described as a teenager explaining a part of his family's heritage. Or you just go back, he has his own kids, he's probably not a teenager. An adult remembering a traumatic event in his or her life. No mention of trauma. We'd want to double check that, but still, a child describing a house. He or she knew it wasn't a child, and it was an adult because the guy has his own kids. So according to the passage, how many bedrooms did the father's house have? You should remember, we've underlined this part. 3-story, 6-bedroom. Bosh. How many bedrooms did the father? Yep, nice. According to the narrator, how does he or she continue to say that his or her grandfather built his house by hand? Oh, that was up here, wasn't it? It says, why not let the legend outlive the truth? Grandfather insisted that, let's see, why did he actually say, what was the reason? It was his crowning achievement in life, he says. That's the reason. It just says that the house was built using his hard-earned money. The grandfather built the house brick by brick. He didn't actually do that. Was particularly proud of the house. Yeah, it sounds. I mean, you'd be proud of your crowning achievement. The grandfather could no longer afford the upkeep of the house. And I see number A. No, there's nothing about the grandpa insisting that the house was built. So, I mean, he's obviously proud of it because it's his crowning achievement of his life. I mean, that, because there's nothing there specifically that's saying that he's proud of it, you have to just assume that, I mean, if something is your greatest achievement in life, you're going to be proud of it. And you can also notice that none of the other ones are actually true, so you could just be left with C. But that's a bit of just inference. It can be understood from the passage that the narrator is all of the following, except... I think I'm going to have to finish reading the passage to get there. The word suburb, as used in paragraph 3, means... Yeah, let's continue on. Spend time there. Christmas was fine, but I also preferred the summer visits. Oh wait, you know what? I've got this laser pen. Yes, so you can see where I'm reading. Oh no, that's not it. Hold on. Laser pointer. Yes, now you can see what I'm reading. Okay. Lancashire life was so different from what I knew growing up in the suburbs. So it's very different. Working a cattle ranch. He was a working cattle ranch and reduced the size of his herd. So, in Bexley we barely had a big enough lawn to have a dog. So he's downsized basically. Doesn't seem to relate to any of the last two questions. So let's do this one because I can see the bold word. Life was so different from what I knew growing up in the suburbs of London. Something of London. We can just see what word fits in there. The city of London, the village of London, the country of London, the outer city of London. It can't be B or C because London isn't a village or a country. And let's just see how we can figure out whether it would be City of London or Outer City of London. So my father's house was they're in Bexley. I had 5 times many cattle. If there's any way to figure it out from the context. Different from the suburbs. No, I don't think there is. I think you just have to sort of know that outer city would work better there than city, and that the fact that suburbs, that's what it means. And if you think it's the opposite of, what is the opposite of suburbs? Let me look it up. Opposite. I would have thought it would be rural. Oh no, okay, so suburb, the opposite would be centre or metropolis. So that's like the centre of a city, and a suburb is the outskirts of a city. At least you've got it down to a 50-50 chance if you've cancelled out the other two, and then you can guess it if you don't actually know what it means. But okay, let's go. Last question. It can be understood from the passage that the narrator is all of the following except traditional. I don't think there's anything about being greedy there. But that area is long gone. My father had 5 times as many cattle. And the ranch house itself isn't even there. Not for the upkeep, so they sold it off. Carved the property into 20 separate pieces of property. My house is no longer standing. Land now belongs to something like 20 separate folders. That's funny. No, there's nothing greedy there. All of the following except, okay. So I'd probably go with greedy. Because there just isn't any tone of greediness. It's just the one that makes most sense, really. You could always double check and see if he does seem nostalgic. The first few paragraphs he is pretty nostalgic. He's talking about the past. Traditional, it's also talking about the past, so you can assume it makes a bit more sense. And respectful, you're pretty much just left with is you greedy or respectful, and you just, by reading the whole passage, try and gauge the tone of the voice of the narrator, and you can sort of just assume that he's not greedy. Okay, let's go on to close Well, not close, but choose the best word. So I think a lot of people struggled on this one. Problem is, I need some charge. Hold on. There we go. Okay, so choose the best word. Fill in the blanks with the word below. Write only the letter corresponding to your answer, not the whole word. Alright, I mean, for this one you can just, obviously you want to read it, but probably read not just up to the blank, but also past the blank, and read the whole paragraph, see what 2 words could fit in there. Once upon a time there lived a king and a queen who had no children. They something very much for a child. Probably something like wished, or something they wanted it, I'd assume. And when at last they had a little daughter, they were both delighted, and great celebrations, I'd assume, took place. Okay, let's look at the options. They misfortune very? Nope. They rejoicing? Nope. Rejoicings took place, that would probably work. They seized very much for a child. They invited 12, longed very much for a child. There you go. They longed very much for a child. None of the other ones fit. Let's move on. When the time came for the little princess to be christened, the king made a grand feast, and something, all but one of the fairies in his kingdom, to be godmothers. I mean, it's got to be invited. Let's see if that's one of the options. Yep, invited is an option. There happened to be 13 fairies in the kingdom, but as the king had only something gold plates, he had to leave them out. I can assume that's going to be a number, because it says there's 13 fairies. The king only had, I'd assume 12. Yeah, 12. Okay, there we go. 12 gold plates. The 12 fairies that were invited came to the christening and presented the little princess with the best gifts in their something. It's going to be something. So we're invited to the christening and presented the little princess with the best gifts in there. Or something that they own. Yeah, so in their possession. Because none of the other ones would fit. Rejoicing, seized. Nope. One gave her beauty, one gave her wisdom, another grace, another goodness, until all but one had presented their offerings. Just as the last fairy was about to step forward and offer her gift, there came a something knocking at the door. It's going to be a sound, isn't it? It's going to be like loud, quiet, something. It's going to be describing the knocking, obviously. So just to look for something that could describe the. It's not going to be misfortune, not a misfortune knocking. I saw a few people write that down. A tremendous knocking. That seems to be the only one that fits. It needs to be an adjective because it's describing the knocking. There can't be anything else. And therefore, anybody could get there to open it. It was burst open. Oh, and before anybody could get. And in came the 13th fairy in a furious something at not having been invited to the feast. I'd assume it's a furious rage or like some sort of fit, right? Because they're not happy. Yeah, looks like L. When she saw all the gifts which the other fairies had presented the child, she laughed and something. Okay, it looks like it's a speech, right? So it looks like the word said would fit there. Laughed and said a lot of good, all this beauty, and yeah. So we just have to look for something that could be replaced for said. and they got exclaimed. You can't be doing anything else. Okay, a lot of good, all this beauty and something and wealth will all do to you, my pretty princess. This one's one I think a lot of people seem to struggle on. What I'd do is, you've only got 2 left, pretty certain with the rest of them, because I think a few words could fit into here. So I'm just going to go to the next one, carry on, try and find what 31 is going to be, just to narrow it down a bit more. So all this beauty and something and wealth will do to you, my pretty princess. You shall pay for the sight. It's probably going to be something good here. Upon to me, then turning to the terrified king and queen, she said in a loud voice, "When the princess is 15 years old, she shall prick her finger with a spindle and die." Having said this, she flew away as noisily as she came. The king and queen were in something, and courtiers stood aghast at the terrible disaster, while the little princess began to cry piteously, as if she knew the fate in store for her. Then a 12 fairy stepped forward. Okay. The king and the queen were in something. Probably some form of sadness. I see. They were in despair. There you go. It couldn't be anything else. So was that J? And a lot of all good. So let's see what we have left now. So we've got F. We've used B, D, E, I, G, L, K, and J. Okay, what we got left? Seized, virtue, and misfortune. So a lot of good and all this beauty and seized and wealth, that doesn't work. You can already cancel that out because you can tell it's going to be something like, it's going to be, well, it's not going to be a verb basically. So it's not going to be seized. So all this beauty and misfortune and wealth will do to you misfortune or virtue. Misfortune is negative. You can assume that it's not going to be that. A lot of people didn't know what virtue was. So, but you can cancel out the fact that it's not going to be misfortune. Because it's negative. It wouldn't make sense if she said a lot of good, all this beauty and misfortune and wealth will do to you. Why would she talk about beauty and wealth and then also put in misfortune there? If you don't know what misfortune means, it's the opposite of being fortunate. Yeah. So what you have left is H, beauty and virtue and wealth. Yep, so that's the best word done. Grammar, spelling. I think this one's pretty easy. I'm not going to go through this. Spelling. It's choosing between its and its. Yeah, no, you guys should find this easy. And these ones, it's just being able to spell properly. If you get it wrong, look it up and write it down in like a notebook and keep a track of all the times you misspell a word. It's just so you can, by the time you get to the exam, you will know which ones you usually spell wrong, and you'll stop spelling them wrong. Yeah. Adding decimals. Let's do some maths. Okay, most people know how to add through the column method. You just add 1 to 2 and you get 3. Add 4 to 4 you get 8. 0 to 0 you get 0. 1 to 2 you get 3. And what you can just look at is the answer to 10 plus 20, or 10 point something plus 20 point something, is not going to be 3,000. What you actually just have to do is just bring the decimal point down with it. And whenever you're adding anything, you just have to align the decimal points and then just add from there, and then put the decimal point down there. So for all of these, you just do normal addition, and you'll get to the answer. There you go. Because 5 plus 8 is 13. Oh, my bad. 5 plus 8 is 13. 2 plus 2 is 4. Plus 1 is 5. And 0. 8 plus 7 is 15. There you go. You just bring the decimal point down, and it'll be the same for here. I'm just reading off the answers now, but you get the point. Subtracting yours is the exact same thing. Let's just do one of them. 5 minus 9. It's going to be 4. That is 1. Put the point down. Two. And 2. Why are the answers a bit weird on here? I don't know how to do column subtraction. I've never done it that way. I'll always just look at the difference and work it out like that. So it will be, if you think about it, 0.21 to get from 40.79 up to 41, and you just have to figure out how much you have to go from here to 62.85. And what's the difference? It's just 21, right? 21.85. That's the difference. So I mean, you just get to a whole number, and get to the actual number, and you just see what the differences were, and you add these two together, and you get 22.06. So that's going to be your answer. See if I can find a column method subtraction.
Look, I do 66 digits. Fine. So in this line, 6 and 7 take, and up the units digit. Starting the right. We're doing collective number. You do is makes that an 8, and like this, and take.
That's what you do. Okay. Let's just go for it. Okay, so you get 5 minus 9. 5 is too small, so you just take 1 from the 7. This goes to be 15.
1 there to turn that.
And 15 minus 9 is 6. And 7 minus 7 is 0. Bring the decimal point down. 2 minus 0, 2. And 6 minus 4, 2. There you go, that's your answer. That's the same thing here. This is just 4.0, and this will be 4.00. So 0 minus 7 doesn't work, so this goes to 3. It's 10 minus 7. what I'm doing here is I'm taking away 1 from here and bringing it to here, right? Hopefully you know that. Oops. 1, 0, there we go. And that's going to be 3, put the dot. 3 minus 1 is just 2, so it's 2.3. And that's how you do all of these. It's normal subtraction, but bring the decimal down. Let's do multiplication. It's pretty simple. You look at how many zeros there are, because we're doing only by 10, 100, and 1,000. Look at how many zeros there are. There's 3 zeros here, so what that means is you just move the decimal point 3 places to the right. So 1, 2, 3. And you might think, oh, there's no number here. You just fill it in with a 0, and now there's a decimal point. So if you rewrite that, 30740 point, obviously you can't just have a point at the end, so just put a 0 there again, and that's going to be your answer. And you don't have to have this section, because that's the same number, but there you go. There's 3 numbers here, 1, 2, 3, 5, 1, 6, 2, 0.0, there you go. 1 number, 1 0 here, to move it once, 403.9, that's where the decimal point is. 2 zeros here, move it twice, 4013.0. This is where the decimal point is. And dividing is the same thing, but just towards the left. So you look at the 2 zeros, that means you can move it 2 places to the left, put the decimal point here. So 0.2867. You just have to rewrite it out, right? 1 0 in the 10. Move it 1 place to the left. 7.778. And this is only works with any form of 10. So if you're dividing this by like 8, you can't move the decimal point. There's no quick method to that. You have to just do the bus stop method. But if you're doing it by 10 or 100, move it 1 place to the whatever, how many places it requires, right? 3. So the decimal point is there, 0, 0. So 0.057.42. Sorry, no point there. There you go. Multiply the following decimals. Okay, these ones. Again, it's just normal multiplication. So 6 times 5 is 30. 6 times 5 is 33 this time, because there's a carried 3. And then 6 times 8. It's a good question. 6 times 8. 48. Plus the 3. 51. And then, because you're going on to the next digit now, you have to put a magic 0. So what I've done is I've timesed all of this, used up the 6 now. This eraser is too big. Okay, I've used up the 6, and now we go on to the 7, and we do the same thing. But whenever we're moving a digit along, we put a magic 0 here. So 7 times 5, 35. Just cancel these out. 7 times 5 is 35 plus 3 now, so 38. And 7 times 8 is 56 plus 3, so 59. There we go. And now we've done that, we just move on to a 2. This time it's going to be 2 magic zeros, because obviously you have to, it always has to be one more. If we move on to another digit, it'll be 3 magic zeros. The magic 0 number always increases every time you move along. So 2 times 5 is 10. And 2 times 5 again is 10, plus the 1 is 11. And 2 times 8 is 16, plus the 1, it will be 17. Now you add these all up together. 0, 8, 9, 6 plus 9, 15, 6 plus 7, 13, and 1 plus 1 is 2. Okay, so now you've got this massive number, and you're thinking, this is basically, if you round this up, this is 9 times 3, right? Which is what? 21. And you're thinking, how have we got 23,000 or 235,000? From that you can already pretty much assume, because if you round it up you're going to get sorry, it's 27. You can get 27. The final result is actually going to be close to that, and you can just assume the decimal point is going to be here, which is going to be 23.5. Makes sense, right? Because it's just a bit smaller than 9 times 3. But how you can do it consistently is you just have to count how many decimal points, how many numbers there are on the right of a decimal point on here. So let me just show you. There's 1, 2, 3, 4 all together. So then you just do 1, 2, 3, 4, and then you put the decimal point there. So let's just do it again here. I'm going to quickly get the result to this. Because I don't think there's any point showing you log multiplication again. So we're going to get 673307. So that's what you're going to get once you've done long multiplication. And you just have to count how many decimal points there are. So that's 4. 1, 2, 3, 4. You just put it here. So that's going to be your answer, 67.3307. Nice. If you don't get this, just write out a few more questions for yourself of random decimal points and just times them together. So do like 7.69 times 5.23 and just try that. Or just keep practicing those random ones. But divide the following decimals. There's also actually a few at the end, isn't there? Yeah, there's a few at the end. So you can always go through these ones. Yeah, let's go through. Let's finish doing. Divide the following decimals. Okay, this one. The year 4s are learning this as well. So you should be able to get this. So 3 into, you just ask how many times does the left go into the right one. So 3 doesn't go into 1. You always start with the 1 digit. 3 doesn't go into 1. So we just ask, does it go into 19 instead? Obviously, if it didn't go into 19, we'd ask, does it go into 192? But okay, does 3 go into 19? It does. How many times? 6 times. And what do you get at the bottom? What do you get as a remainder? It's 1. But let's not think that fast. Let's just think what 3 times 6 is. It's 18. And then you can minus it and then you'll get the remainder there, instead of having to think of the remainder, right? So what I do is, what you should always do is ask how many times does the number go into this. It's 6 times. And then you times this by the top, and you're going to get 18, which is a number you've probably been thinking of anyway. And then you minus it and you're going to get the remainder. And that way you don't confuse yourself by finding the remainder and placing it somewhere in the bus stop where it's not meant to be. Okay, so we've got 1 now, and usually you'd ask how many times does 3 go into 1. It doesn't. So what you can do is you can bring the 2 down, and now it's 3 into 12. A lot of people will do it differently and will just put the 1 up here. Either way is fine. But either way, you're asking how many times does 3 go into 12 now. And it does 4 times. So you put the 4 up here. And then you just do 3 times 4, and you're going to get 12. So this shows you that the remainder is 0. Again, ask the same thing. How many times does 3 go into 0? It doesn't. So you bring the 3 down. Now you can ask how many times does 3 go into 3, or 0, 3, which is 3. And it goes once. 3 times 1 is 3. You get 0 again. Bring the 8 down. How many times does 3 go into 8? Twice. You're going to get 6. And the result is minus 2, sorry, it's 2. And now we come across a decimal point. So, I mean, all we really have to do it just moves that decimal point up here, and that actually gives us the power to add zeros to here, right, when it doesn't fit. But we can ignore that for now. So now we've moved the decimal point up. Does 3 go into 2? It doesn't. Because there's still a number here, we bring that down. So it's 2 into 7. 27. And does 3 go into 27? Yep, 9 times. And what do you get? You get 27. And the remainder is 0. So that's your answer. And let's do this one, see if it's any different. Now I think they're all going to come out as whole numbers. Anyway, so 7 into 3 doesn't work. 7 into 35, it does work. It's 5 times. Put the result here, and you're going to get a remainder of 0. So you bring the 3 down, and you ask, does 7 go into 3? It doesn't. Well, now that's a problem because if 7 doesn't go into 3, we have to bring another number down, which will be 7 into... Oh no, sorry. Because 7 doesn't go into 3, what we have to do is put a 0, and then we can bring down another number, so 35, which will now be 7 into 35. Is 5, obviously, and we can put the result down here, and you're going to get 0. Now we have to bring the 1 down, and now we have a problem again. Does 7 go into 1? It doesn't. So again, we put the 0 here. Now we can bring down the 4. But remember, when you come across a decimal point, you have to move that up. And so now we've got, does 7 go into 14? And what you're going to get from that is 2. And yep. So 0. That's your remainder, and that's your answer. It's a bit confusing, but basically if a number doesn't go in, like we had there, it was 35. You got 0. We brought down this 3, and the 7 didn't go into it. So we just have to put a 0 up there, bring another number down, and carry on. So it's remembering that, it's remembering putting a 0, and then also just remembering to copy the decimal point whenever you get to it. Copy it up. But yeah, do the rest of the optional work, and if you get stuck, look at this explanation. It should help you get there. These ones are easy. Yeah, there's not much to teach here. Okay, let's move on to rounding the following decimals to the nearest tenth. Okay, so a tenth. It just means a tenth, 1 over 10. And think of what that is as a decimal. It's 0.1. So that means to round to the nearest 0.1. So that means it should only have a digit in this place and not a digit in this place, right? So if I said round to the nearest 100th, that would be 0.01. And then you'd have to have a digit in this place as your rounded thing, right? So basically, we need to only have one number behind the decimal point. So because the 4 is small, we can round that down. So it's going to be 3.5. If it was 5, we round up, obviously, and if it's anything below 5, we round down. So here, so it's bigger, so it's going to be 3.07. Sorry, might be confusing you. You always have to look at the number past the one that you're rounding up to. So we're looking at the 3, and does the 3 round up or down? It rounds down, so we just keep the 7 the same. And up here again, we're looking at the digit behind the last one, because remember we're only rounding up to here. So is it 4? It rounds down, so it's going to be 3.8. And then here we go, we've got one that rounds up, so 6 rounds up. So we're going to move this 4.5 up by 1 to 4.6. Okay. Hopefully that wasn't too confusing. Yeah, there we go, round to 2 decimal places. That's just the same thing as I showed up here, but it's in different words. And most people know what 2 decimal places is. It means these two. So that means we look at this one. So is a 7 bigger than 5? Yep. So we're going to round up. We're going to round up the last digit, obviously, from 2 to 3. This one is going to round down. This one's going to round up. This one's going to round down. Okay, converting between fractions and decimals. How I like to think of it is usually, if you remember from last month when you learnt equivalent fractions. If you don't remember this, you need to revise it. Maybe look up a YouTube video on equivalent fractions, or I'll give you a quick explanation here anyway. Most people, they'll be able to tell me that 90 over 100 is 90%, which is just the same as 0.9. So you can say 90 over 100 is 0.9. So obviously 9 over 100 is 9%, which is therefore 0.09. Yeah. So what that tells us is, if we have a fraction over 100, we can just quite simply figure out what decimal it's going to be. So if we change this to be a fraction over 100, if you're doing equivalent fractions like we did last month, all you have to do is ask what happens from 10 to 100. You times it by 10, and then what happens from 9 to, you do the same thing. So you're going to get 90 over 100. So these are the same fraction. And from here, you should be able to tell me that this is 90%, and that is therefore 0.9. So it's going to be B. And for 79, it is, let's transform it to have 100 at the bottom. We're just going to times it by 10. And that's 30%, or 0.3. And this one, 4 into 100, might be a bit more complicated, but you just times it by 25. And you times the top by 25 as well, you're going to get 50. So 50 over 100 is 50%, or 0.5. And converting back is the same thing. Again, because you know 0.8 is 80%, and 80% is just 80 over 100. Because what a percentage is just any number over 100. Right. It's 100 wholes. No, 100 is one whole separated into 100 fractions, 100 parts, and it's just 80 of it, right? So 0.8 is 80 over 100, and then you just simplify that until you get one of these. So if we simplify it, we can cancel out the zeros. 8 over 10. Then you're going to get, if we just divide the top and the bottom by 2, you get 4 over 5. There you go, A. So here I'm assuming you know how to simplify, and I'm also assuming that you know percentage. You understand what percentage is. So if you don't, let me do a quick explanation. Okay, let's imagine cake split up into 100 parts. Just imagine that's 100 parts. If you get 80% of the cake, you're going to take 80 of the 100 parts. Or an easier way to explain it is if you have 100 marks in a test and you score 80, that's going to be 80%. That's going to be your score, 80%. So always think of a percentage as over 100. Now, if I told you that 80 over 100 is not equal to 1 whole, you should be able to understand that, because 1 whole would be 100 over 100, right? So the number 1 is 100 over 100, as if you got 100% in the test. So what would 80 over 100 be? It would be 0.8. It's not a full number, is it? It's not a whole number. So you don't really need to understand it. All you really need to know is that you can convert it like that. And therefore, if you look at that, you should be able to figure out that this will just be 40 over 100. You just look at that a bit. Because basically what's happening here is over 1, right? And what you're doing is you're timesing this by 1,000, timesing the top by 1,000. But this might be getting a bit too confusing for you while I'm trying to explain the intricacies of it. So all you need to remember is you can just convert this to 40%, and you can convert it to 40 over 100. And then once you've got that, you have to figure it, you have to ask, if you want to simplify a fraction, you have to ask how many times does any number go into it. You have to choose a number, ask how many times does it go into it. So if we choose 10, how many times does 10 go into 40? Well, it does. And does it also go into 100? Yep. So you just divide the top and the bottom by that number. So 40 divided by 10 is 4. 100 divided by 10 is 10. And now this is a lot easier to simplify. We have to choose another number that will go into both of them. I'm going to choose 2, because 2 often goes into all of them. And if you divide the top and the bottom, you can get 2 over 5, and there you go, B. And just the final one, again remember, you can always convert it into a percentage. 87.5%. Why? Because you move the decimal point 2 places to the right, yeah? So 87.5%. So always, that's the percentage, if you think of it like that. And that, it just ends up being 87.5 over 100. Now, that makes it a bit confusing, because you've got a decimal in a fraction. So again, just use your equivalent fractions knowledge and make it into a whole number. So we can do 875 over 1,000 instead. Now we've got a massive number, and we have to simplify it. So what number goes into both of them? It looks like 5 does, but I'd also say 25 does, because 25, 50, 75, and you can see that works, right? So let's go with 25, be a bit quicker. You divide the top and the bottom by 25. 25 times 4 is 100, and 4 times 8 is 32, and then 32. So 25 times 32 is 800, and you just add 3 to that, so it's 33. And that's just going to be 40. You can work that out long form if you need, and we just have to simplify that even further. What number goes into both of them? Oh, I got that wrong. Okay, here we go. Yeah. (32 + 3 = 35). I don't know how I got that. Yeah, there we go. So then now we can simplify that. And you get 7. Sorry, I choose 5. You get 7 over 8. Bosh. Nice. Okay, we're nearly done. Nearly done with the whole homework. Let's go on to... Oh, there's a lot of analogy. Okay, this is simple. Yeah, all of this is really simple for now, at least. It'll get more complex, but you have to read the instructions, because you're not always going to get a question that you've seen before or that you're familiar with. Like in the Kent test this time around, there was a new question type, and because people don't know how to read instructions, they just skipped it and lost all their marks on it. So you have to read the instructions. They're in simple plain English, and if you just understand that you have the ability to understand instructions and you can apply them, so you don't actually have to have done a question type before. You should be able to figure this out without having someone teach you. If you get too reliant on being taught all the time, when you get something new, like in the exam this time around, you're going to get them wrong. So read the instructions. It says using the rules of change for the two shapes on the left, find a matching pair for the sample shape. Okay, so there's a rule of change between the two shapes on the left. So that means something is changing from here to here. Find a matching pair for the sample shape. So here's the sample shape. A matching pair means when you have to find one option that will match it using the rule. So we're gonna need basically this to be replicated here. So let's figure out the rule first. What's changing from here to here? It's just going black. So we're going to have to do the same for the sample shape, make it black, and then choose an option. Can't be C because that's a different shape. Can't be B because that's white. These are the different shapes as well, so it's going to be D. That's the matching pair. Now we just do the same thing on all of them. So what changes? It goes white. We're going to have to find a white option of this. It's B. What changes? This goes smaller, so we're going to have to find a smaller option. That's B. Has to be the same, right? Yep, it can't be that because the arrow is pointing the other way. And what changes here? It looks like it's been reflected, and then it also goes black. So let's reflect this. It's going to be a left foot to a right foot, and it's also going to be black. So C. And this one, again, what changes from here to here? It's been reflected and then there's another line added. So let's reflect this. We're going to get this, right? And then we add another line, so it's going to be 3 lines. Oh, no, sorry. It loses a line. Okay, so it's going to have 1 line. Yeah, there you go, see. This one is reflected and then the pattern seems to change from lines to dots. So let's reflect it first. This isn't a reflection. These two are reflections. This is a reflection. Okay. This isn't a reflection actually, because if you look at the shape inside, it's the same. So it could either be C or E. And what we see is the pattern has changed on these two. Pattern hasn't changed on C, so let's just go with E. This one just seems to rotate 90 degrees. So let's rotate this 90 degrees. We'll get E. Pretty blurry, but for 89 I think the answer says it's C, and it might be because of this weird looking pattern. I mean, the pentagon isn't really regular, but I'm not too sure about that. I do think the pattern should be changing because it goes from dots to lines. So I'd assume this one would go from dots to lines as well, but you really can't. I mean, like this still looks like dots, so, and you can't really tell if there's a pattern there or not. The answer says C. I'm gonna make it so it gives you a mark if you put E as well, though, because I think the printing is the quality of the question is what's ruining it there. Let's go to 91. This looks like a reflection, but also looks like the arrow is getting thinner. So let's reflect it. So I don't know if that's going to be part of the rule, but let's reflect it first. Oh, that's not a reflection. That's not a reflection, and that's not a reflection. That's also not a reflection, because the pattern is the same way. So it's gotta be B. .92. This one just rotates. Let's rotate this one. There you go. A. This one, the thickness from here to here looks like the change. This one starts being thicker, and the inside gets unthicked, and then also the center gets thicked, and the line seems to swap thick. So it looks like it's just the change is just all about line thickness. So I'm gonna assume, because this one changes to the left, this one is gonna change to the left. So let's look for one. Yeah, I'm gonna go with C off the bat, just because it's that. Actually, you know what? That's not. I'm not sure about that. Let's see. What else could change? The circle becomes thick, so I'd assume these ones would become thick. But this outside layer shouldn't be thick anymore, because that should have swapped. Oh, there we go. Yeah, D. Yeah, I missed that for some reason. I didn't see that this was also thick. Yeah, there you go. 3, D. This one is just rotated again. So let's rotate it. People got this one wrong, I remember. So when you're rotating it, think about rotating the shape inside as well, because that's a bit easier to think about. So if you rotate this 90 degrees, bosh. And if you rotate it again, you can get it like that. Or just spin it around. So you have to look for one that matches that. You're left with, and this one's white, so you just go with D. This one's reflected from there to there. Then you also add a line. So let's reflect this. you're left with A, B, and D. You also change color, so you're left with B, and you add a line, so you're left with D. This one's a bit difficult, but let's break it down. What is the change from here to here? The arrow seems to get reflected. It goes, yep, so half of it gets reflected. And then it looks like this little glass thing gets turned upside down. And also the stuff inside it gets turned upside down. There it says, no, actually it doesn't. This looks like the circles stay in the same place. So that could be it. It could be that the glass is getting turned upside down, but the circles stay the same. Or it could just be a reflection across the vertical axis, like this. That's probably more likely. So it looks like half of it's getting reflected horizontally, and the other half is getting reflected vertically. So let's reflect. I'd probably reflect this one horizontally. Oops. And we're going to get something like this. Cancel out a few of them. You can cancel these ones out. And the remaining shape, which is the arrow figure, we're just going to reflect that vertically. So you get the same thing, but you get these ones up here now. So we just have to look for one that matches that. It doesn't seem like any of them match it. Apart from A is the closest. But for some reason where the triangles have swapped colours when they didn't, the circles didn't swap colours in the first object. I mean, didn't swap, yeah. Let me check what the explanation says. So the black and white shapes have stayed the same. Well, they haven't. Wait, hold on. 1, 2, 3, 4. So jointed line arrow has been reflected in a vertical mirror line. Jointed line arrow. The 4 line arrows have been reflected on a horizontal mirror line, and the black and white shapes have stayed the same between the wider spaced lines / arrows. I think it might be a mistake in the question. I think it's meant to be black, like this. Because otherwise it's not a reflection. Could be like that. I don't know, but A is the closest one. So I'll go with it. I mean, the explanation says that the shapes have stayed the same, but they haven't. It is what it is. Let's move on. You can always write in the comments if you figure it out. Like last time, there was someone that showed me what I did wrong on the last question. There's always a few of these questions that I seem to struggle on, but okay. Hidden word. Just a quick tip for this one. How you probably want to do it is always look at the first 3 letters of the word on the left and one on here, and that doesn't work. So then just do this, and then do that. Right? You can look at all of these. How you can do it is just put your thumb, cover the left 2 letters, and you get Eri. I'm making it complicated. Okay, let's look at just the 4 letters. That doesn't work. So then you do rice. That doesn't work. And then that's too short, so it can't be that. So you move on to the next one. Is to. Nope. Stew. Nope. That can't work. We have to move between the next one. So Uma. Nope. Umuk. Nope. Or tomb. No, not really. Okay, so we use 3 letters from the left and 1 letter from the right. It's Uche. No. Chi. Nope. Here. Yeah, there we go. Here. So again, just use 3 letters from the left, 1 letter from the right. Theb. Nope. 2 letters, 2 letters. Hebi. Nope. 1 letter, 3 letter. Ebir. Nope. So we move on to the next gap. Iruds. Nope. Rudisat. Nope. And Desat. Nope. So Sato. No. Aton. Nope. Ton is too short. Let's move on to the next one. Onth. Nope. Nitha. No. Next one. There. Not spelled correctly. Hero. Yep, there we go. So yeah, that's how you do it. That's how you brute force it. And if you want to do it a bit quicker, when you're looking between the gaps, if there's not enough vowels there, like huts, there's no point looking there. Just cancel this out. Look at the next bit. Oh, you already got it. Game. And again here, not many words have TT in it like that. TTH. I mean, I don't think that would work. So I'd just not look at this at all. I look at the next gap, which is Yov. Doesn't seem to work. Yovi. Nope. The words don't seem to work. Look at the next gap, and you get vent. So yeah, there you go. And that's all of it. But yeah, you should never be stuck on this, because you can always brute force your way to finding an answer. So it should always just be a matter of, if you're given unlimited time, you should be able to find the hidden words, because there's only a certain number of possibilities. But that is homework 4, and I know it's a bit late, but hopefully if you're stuck on anything, it was helpful. Alright, see you in a bit.